right, guys, let's talk a little bit about some more complicated rational functions. Specifically, we want to look at their asymptotes. Okay, this is the part of their behavior that's easiest to predict just by looking at them. So first, we're going to deal with vertical asymptotes. Now, remember earlier we dealt with 1 over x, and as x got closer and closer and closer to 0, we saw positive infinity and we saw negative infinity. And then right at 0, we saw this vertical asymptote. Well, it turns out that's going to be the case on all of these. When our denominator equals 0, that's where you're going to see vertical asymptotes. So let's start with an easy one. This guy right here. Well, when does x minus 7 equal 0? Well, that's when x equals 7. So we're going to see a vertical asymptote on the line x equals 7. So if we're graphing this guy, okay, we're going to see something along those lines. And once we graph the other asymptote, we're going to have a really good idea of what's going on here. Well, let's look at this guy, find its vertical asymptotes. Now, this is a degree 2 polynomial. So how many times can this guy equal 0? Well, up to 2 times. So if I take a look at this, I could do like quadratic formula and stuff, but I'm pretty sure here I can do, oops, I guess this needs to be positive, doesn't it? X minus 2, x minus 3. Okay, well, what does that mean? That means that we're going to have vertical asymptotes at x equals 2 and at x equals 3. Okay, we're going to have multiple vertical asymptotes here. What about this guy? Okay, x squared minus 9. It may be a minute since you've done this. We can use difference of squares factoring on this. X plus 3, x minus 3. So we should have 2 vertical asymptotes at x equals negative 3 and x equals 3. But if you graph it, it doesn't. It doesn't have 2 vertical asymptotes. So you're like, Mr. McClellan, are you a liar? Yeah, kind of. So what you'll notice, yes, we have 2 factors here. It can equal 0 2 different times. But what you'll also notice is on top, we have an x plus 3. So I can actually simplify this. And really what I'm staring at is the graph of 1 over x minus 3, which is only going to have 1 vertical asymptote at x equals 3. Okay. So what's going to happen here? Because I'm still not allowed to divide by 0. Well, all we're going to see is when we draw this graph here in a minute, okay, no spoilers here on the asymptotes, but at negative 3, we're just going to have a little hole, a little tiny hole here where x equals negative 3 should have been, but no asymptote because that factor canceled out on top. All right, I'll take this away. And then this guy, very simple, x minus 4. So our vertical asymptote is going to be x equals 4. All right. So we found our vertical asymptotes. Again, very simple. We just take the denominator. We go, hey, when does this guy equal 0? And when it's complicated like this, you can either use factoring, you can use quadratic formula, whatever it takes to find what you need to find. We could have even said x squared minus 9 equals 0 and done the square root. Okay, either way. But that's how we find our vertical asymptotes. So what about horizontal asymptotes? So let's hop back to our parent function for a minute, our 1 over x. Well, we had this horizontal asymptote at y equals 0. Well, why did we have that? Well, the horizontal asymptotes is the limit as x goes to infinity or as x goes to negative infinity. In other words, what happens when x gets really, 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 really big? Okay, that's what we want to know. Okay, what's going to happen as x gets huge or really, really small on the negative end? Okay. Well, it turns out with these rational functions, we wind up seeing basically 3 different patterns. And it all depends on the degree of our numerator and our denominator. So let's say we've got these guys right here. Okay, our g polynomial and our h polynomial. Well, the first thing that's going to happen if the degree of h is bigger than the degree of g. So let's see what happens when our degree of h is bigger than our degree of g. So here's an example over here. This guy right here is a degree 1 polynomial, and this is a degree 0 polynomial. So this guy has a bigger degree than this. So let's see what's going to happen here. So x is going to get really, 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 really big. So it's 4 divided by like a billion. Well, what happens if we take 4 pizzas and slice them into a billion different pieces? Well, those pieces are going to be about this big. We're going to get closer and closer and closer and closer and closer to 0. Okay, so the limit is going to go to 0. So in this case, where the degree of our denominator is bigger than the degree of our numerator, the horizontal asymptote is going to be y equals 0. We get closer and closer to 0 as x gets huge. So what does that look like over here? Okay, something like this. I'm just sketching it. May not look exactly like this, but that is kind of an estimate here. Okay. So again, what if our degree of h is equal to our degree of g? Okay, so that's another case that we need to consider here. So look at this, for example. This is degree 2, this is degree 2. So these polynomials have the same degree. So what do we want to know? We want to know what happens when x gets big. What happens when x gets huge? Well, we say, okay, as x gets huge, this guy starts to swamp these two guys. Okay, as x gets huge, x squared is going to be so much larger than these terms, they're basically not going to matter. Okay, and then same thing down here. X squared is going to get so huge that these guys aren't really going to play much of a role at all. And so we get 3x squared divided by x squared. Yes, there's a little bit of leftover, but just barely enough that it even matters as x gets huge. So what is 3x squared divided by x squared? Well, that's just 3 over 1. The x squareds cancel out. So it winds up being 3 over 1. So our y winds up being, sorry, making sure we're on the screen here. Our leading coefficient divided by our other leading coefficient. All right. So we've got one other possibility that we need to wrangle with. What if our degree of h minus 1 equals our degree of g? Okay, so our top degree is bigger, but only by 1. Okay, so let's think. What's going to happen as x gets really, 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 really big? Well, what's going to happen is our numerator is going to grow faster than our denominator. This guy's going to get really, really big, and this guy's never going to catch up. Okay, so what happens is this guy starts to take off. Now, if it's like 2 or 3 or 4 degrees higher, then it starts taking off really fast in like a quadratic way or a cubic way or whatever. But when it's only 1 power more, we're actually going to have an oblique asymptote that's a line. So how do we find that? We're going to take this and we're going to divide. Okay. So what do we have to do to get from x to 2x squared? Well, we need 2x. Okay, drop this down. We wind up needing 13, 52, and then we wind up subtracting. So what is that? Like 40, 45, I think. And here's the thing. Technically, it's this plus 45 over x minus 4. But here's the thing. As x gets huge, this guy starts to go away. And then our asymptote becomes 2x plus 13. We get closer and closer and closer to this line. So we get this oblique asymptote right here. So I believe this graph would look something like this. By the way, I forgot to graph this guy over here. So let's just graph this. We said y equals 3. Okay. This guy, I'm not sure exactly what it would look like without graphing, but this is, those are our asymptotes right there. So to review, how do we find our horizontal asymptotes? Well, our horizontal asymptotes are whenever our denominators equal 0. Did I say horizontal? Or vertical asymptotes. Vertical asymptotes are when the denominator equals 0. What about our horizontal asymptotes? Our horizontal asymptotes, it depends on the degrees of the numerator and denominator. If the denominator is bigger degree, it's going to get huge, and y is going to equal 0. That's going to be our horizontal asymptote. If the degrees are the same, you look at the leading coefficient, and it's going to be the ratio of the coefficient. If this degree is 1 more than this, then you can do synthetic division, not synthetic division. You can do long division and find the asymptote that way. Whew. Okay. Good luck on that. I don't think you have any oblique asymptotes on your homework, but it's good to know. So